To make it easier to work with patterns and pattern matching, a language feature called switch expression was introduced. This combines the idea of a switch statement and the expression-bodied members. The purpose of a switch expression is to use patterns to evaluate which value to return. The syntax looks slightly different from using a switch statement. As opposed to a switch statement, the switch expression returns a value. The switch expression has a few important components. First, you start off with where you'd want to put the result. This could be assigning it to a local variable. On the right-hand side of this assignment, you first indicate which value, tuple, or object you want to produce a switch expression for. With a normal switch statement, this is what you'd use in the parentheses after the switch keyword. So really, they're just flipped around. This way of writing the code makes it more fluent to read, as you clearly state that the result will be based on the object, and then we have the different patterns. Each case consists of a pattern and an expression. The expression has to return a value. All expressions need to return types that are compatible with each other, or that define an implicit conversion. For example, one case can't return an integer, while the other returns a string. That really doesn't make any sense. The pattern can be simple or complex, and you can combine multiple patterns, which is known as recursive or nested patterns. It's important that your switch expression has patterns defined for all different cases. I'm definitely not suggesting that you produce complex patterns for the sake of adding more patterns, but you should never forget to catch the default case. This is when there's no other match. You can easily catch everything by using the discard pattern, and this will match on null as well. If you forget to add a default case using the discard, and the switch expression does not define a pattern that matches the object, you will end up getting a switch expression exception saying that non-exhaustive switch expression failed to match its input. You may want to produce an exception on your own if that's the case, but at least you intentionally handled that case. Just like a normal switch statement, the order of the cases matter. You want the most granular patterns at the top. If the compiler notices that you have a pattern higher up in the switch expression that is less granular, it will give you a compiler error, as you'd have unreachable code. Let's say that we'd like to calculate the freight cost for an order with the help of a new method that uses a switch expression. There might be multiple business rules to change the outcome of how much it costs to ship an order. We can do this calculation in the order processor. Let's introduce a new method that returns a decimal and call this calculate freight cost. This will accept an order as the only parameter to the method. Introduce a new local variable called freight cost, and based on the order shipping provider, we are going to determine if this matches a few of the patterns defined by the business. Inside the switch expression, we can now look at the shipping provider. If the selected shipping provider is the Swedish Postal Service shipping provider, this means we will use the type pattern to look at the actual type of the instance. Then, we are going to consider the shipping free. However, with the Swedish Postal Service, if you've selected next day shipping, we'd like to make it a little bit more expensive. We can do this by combining two patterns, the type pattern and the property pattern. First, we specify the type. Then, to access a property, we use curly braces, and then the property that we want to match a value on. If this is added after the other pattern, you'll notice that the compiler produces an error. It will tell us that this is unreachable because it's already been handled by a previous expression, or if the compiler determines that this is an impossible match. The type pattern defined above is a less granular pattern. It will match on all the shipping providers of that type. It's easy to fix this. We can simply move the switch expression that we just added above the other one. Finally, we'll add a default case, and that is done using the discard pattern. For all other shipping providers that do not match our criteria, we'll set the cost to 50. We can then return the freight cost from the method. We've now successfully introduced our first switch expression. This makes the code easier to read, and it's easy to change and add more patterns. You don't have to store the result that is produced by the switch expression in a local variable. You can make this method a little bit less chatty by directly returning the value produced by the switch expression. We can even take it one step further. A huge benefit of the switch expression, as opposed to a normal switch statement, is that we can use this together with an expression-bodied member. Making this change is easy, and with very minimum effort, we've changed this, and it's now become an expression-bodied member. You've seen a few of the patterns that you can use already, and together with the switch expression, this becomes a really handy language feature that will definitely change the way that we write our code. We'll now continue through this module and explore the different patterns that you can use.